From the classroom to the workplace, we work, we work. When we see the complete picture, we work in the classroom towards our future. We work.
I'm James Husbands, Managing Director of Solar Dynamics Limited. We have two operations, one in Barbados and one Solar Dynamics EC Limited based in St. Lucia. Solar Dynamics was established in 1974, and it's based on a concept of lower cost water heating, and this was an idea of the Reverend Andrew Hatch, now Canon Hatch, using the Brace research information, which would have looked somewhat like this when we first started. The materials there would have been half of an oil drum as the receptacle bringing in the water, then an oil drum with bagasse, and a collector made of galvanized pipe with aluminium transfer plate in a wooden box. So that's the genesis of our product. Through the years, we've made improvements, and then we went to metal enclosures, and then we went to using copper materials, and then we changed from vertical tanks to horizontal tanks. So right through the years, we've probably done about 16 different designs and probably 24 improvements on the solar water heating concept. To explain a little bit about solar water heating, generally a resistance element, one or two of them looking like this, are placed in a storage tank very similar or identical to a solar water heating tank, and of course using a thermostat to control temperature. The electric resistance element being heated up would then absorb the water would absorb the heat on this element and produce hot water. So in producing a solar water heating system, what we're in actual fact doing is eliminating the need to use electricity that you would use with this element and to use the sun instead. The solar water heating system has two components: the collector, where the heat of the sun is absorbed onto a copper, or in some cases an aluminium plate, and on that plate you have bonded a series of tubes. The storage tank is comprised of an insulated tank. This is what you see here is really just a cabinetry. So you have an aluminium enclosure, and we've chosen aluminium because it has the longest possible life of the materials that are available. And as you know, the raw materials for aluminium sheeting, a lot of it is found in the Caribbean, in Jamaica and in Guyana, Suriname, bauxite. So that's one of the raw materials. When processed, gives us a material that does not corrode as easily and does not rust. So some of these enclosures have been there for 30 years and still looking good. So we choose copper for the collector plate to absorb the maximum radiation, second only to silver, and silver is unaffordable for this application. We use the aluminium cabinetry, and of course the pressurized tanks on the inside. So insulation wise, as you would have heard, in the early days you would have used bagasse, and of course we used bagasse even at Oxnard's back in 1976 when we did those units. The original units would have been glass-lined steel tanks with bagasse as the insulation, and they would have had masonry enclosures. When we talk about the solar collector panel, we insulate the back under the collector as well as the sides to ensure that we get the maximum heat from the sun. The glass you see is tempered glass. Tempered glass is 3 to 4 times stronger than regular glass, and of course it will not break as easily. The tempered glass is important, particularly because of our location. We have storms, hurricanes, and we want to, if it does break, it will shatter into fine pieces. The basic principle of the system is that you're utilizing the 3 basic laws of physics. So you have incoming radiation from sunlight. Then by conduction, that heat moves from the hot area to the water in the tubes. And by convection, because heated water is lighter than cold water, the heated water rises to the top and comes into the upper layer of the storage tank. So the convection flow, the cold water then from the bottom of the tank replaces that heated water. And so you have that convection cycle in the similar way that hot air rises and cold air comes in to take its place. It applies to what we call a convection flow solar hot water system. Sizing of the system is one of the most important challenges that you would face. Remember that you have to have enough in storage for tonight's use and tomorrow morning as well. We typically size 15 to 20 gallons per person at maximum occupancy. And where there is commercial use, of course, you'd have to look at the activity. For example, this system has a capacity of 160 gallons. They're 2 80-gallon tanks, and they're served by 2 panels each. So in that way, we're projecting a temperature of 140 degrees Fahrenheit or 60 degrees Celsius by 160 gallons. And we've determined that this will be adequate for this segment of the facility. Now there are four sections of the facility which need hot water. And locating a system close to the demand is important, so you don't have a long runoff when you install the system. So the time it takes for the water to get to the bathroom or to the kitchen is determined by how the length of pipe run between the storage tank and where you need the hot water. The solar hot water system can work at ground level, or it can be at rooftop level. There's some, I think probably 2% of the systems have been installed with the tank at a lower level than the collector. So in the normal scheme of things, if you had a system installed at ground level, you'd have to be concerned about shading of trees or shading of the house. And if you don't have enough adequate space far enough, you may have a bit of a concern. Now, the natural convection flow with the tank higher than the collector means that you do not need any mechanical or electronic devices for its day-to-day operation. When a tank is required to be lower than the panel, then we have to force the circulation between the panel and the storage tank. And that is referred to as a split system or a force circulation system. In that case, what we use now would be a DC pump, a direct current pump, and that direct current pump would use a PV panel such as this, a 10-watt PV panel. That PV panel would produce the electricity, and the pump will run using solar electricity instead of the normal AC electricity, alternating electricity. But essentially, those are the two principal methods: convection flow and pump or split systems. So solar energy has been the traditional energy that has been there for mankind. Its widespread use is more available today than ever before, based on the cost reduction of the use of different materials. The widespread use of solar energy, therefore, is here for each and every one to benefit from, to reduce our costs of living and to improve the quality of life we enjoy.
The workplace we work, the complete picture. We work in the classroom towards our future.